Good morning. My name is Ronald Bartels. I'm from an SD-WAN company called Fusion Broadband, and we provide services within South Africa. Today, I'm going to chat to you about monitoring of links, and usually the problems that people encounter with monitoring links. So the actual problems that have been around with monitoring links have been around since way beyond just the past couple of months, the past couple of years. I'll go back to round about the year 2000, and round about the year 2000, I was working at a bank. Our manager at that time decided that outsourcing was a good thing. Often in companies, and especially large organizations, there's a cycle of insourcing, outsourcing, IT work going out, IT work coming back. And at that moment in time, the flavor of the month was that we were going to outsource monitoring of computers and monitoring of the network. So in came a company, very well-known company in South Africa, won award with Cisco year after year, and they claimed they knew what they were doing. So they were basically at that moment in time using a product from a company, I think it was called Concord, but the product was called Network Health. And what this did, it monitored service, network link, it did the standard SNMP polling of devices, displayed them on a web interface, and Bob's your uncle. So they started monitoring the links, and there was problems with the links, and they blamed the computers and they blamed the network and everything else beyond that. So after a month or so, I decided, no, I was going to investigate this. And one of the first things I did was install monitoring software on the link that they were using. So the link between their network operations center and the bank was 128 kilobits per second DigiNet link. DigiNet was an old TDM service that was sold by Telkom in South Africa. In any case, the first thing that I noticed when I started monitoring this link was that it was reporting errors. And I could see by looking at the traffic that there would be a burst of traffic which would overflow the queues, drop packets, and chaos would erupt. So I thought, yep, I've identified the problem. So I phoned up these guys, and they said, no, they're going to come through for a meeting. In those days, video conferencing wasn't that big a deal. People would often have conferences around a table. So they rocked up, and I said, no, there's a problem with your link that you're using. It's undersized. So they hauled out a graph and they said, no, it's not. It's 128 kilobits per second link, and it doesn't go over 64 kilobits per second. So I looked at their graph, and yes, it was running an average of 64 kilobits per second. However, they were doing it at 5-minute intervals. And these bursts were happening in a couple of seconds. And then, so what would happen is the server in the NOC would poll the server at the bank, request some information. It would try and send the information back. That information that was going back would obviously saturate the 128 kilobits per second link, drop the packets, and then things would slow down again, or be retransmissions. So they said, well, I said, well, you're monitoring the thing at 5-minute intervals. You should be monitoring it at, less than that. You should be monitoring it at the second level to see the particular error that you're going. But why are you monitoring the actual bit rate on the intervals? Why aren't you logging the errors? And they said, no, they don't monitor the errors. And this carried on for quite a while because they said, no, they don't. They logged on to their router on their side and they don't see any errors. So I asked, have you logged on to the router at our side? No, they haven't. Well, if you logged on there, you'd see the errors. In any case, this whole episode made me doubt their ability to, first of all, provide networking services. I don't know how they could have provided network services to such a large number of companies in South Africa and have done it effectively. They must have been very good at their salesmanship. Regardless, the network monitoring in that configuration wasn't going to be accepted by me, and they were quite upset about it. And I said, well, if you can't monitor your own link, you're not going to monitor anybody else's servers or anything else like that, because you need to be competent in what you're doing to be able to pick up that your link is actually saturated. However, this particular thing, although it happened 20 years ago, still exists in exactly the same fashion. And I look at modern day ISPs, they actually don't have the concept of a poll happening every 5 minutes and that's a 5-minute average. So if something is running at, let's say for argument's sake, 50 megabits per second over 5 minutes, that does not mean that the link doesn't go to 100 or higher during that 5 minutes. It just means it's averaged out. So if at 3 minutes, 30 seconds, you have 20 seconds of high utilization and everything slows down, it doesn't help you go back to the customer and say, no, you didn't go over 50 megabits per second. You know, the customer experiences during that time period, things were slow. The second thing about it is that a lot of these ISPs, they actually monitor from their core to the edge. Latency is a very good example of this, and packet loss. You know, they're monitoring from the core through to the edge. And there might be no packet loss in that area because there's very little traffic on anybody's uplink, because traffic is usually asymmetrical, meaning the downlink is usually higher than the uplink. But if we do the reverse and you're actually monitoring from the customer edge up into the ISP core, you actually see the packet loss and you actually notice that things aren't correct. But the ISP says, no, I don't see any problem, so there is no problem. So the thing that you have got to do is you've actually got to monitor the downlink, not the uplink. And you've got to monitor it from the customer perspective, not from your perspective of the ISP core. So 20 years later, we still have exactly the same problems where people do not understand how to monitor a link correctly. And there's a whole lot of finger pointing to and fro where they say, we don't see a problem. So because we don't see a problem, there isn't a problem. And that because you are experiencing a problem, it is your computer, it is your LAN, it is your router, blah, 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 everything except taking responsibility that it's their problem. Often with ISPs, they actually do something called policing, which means they sell you 100 megabits per second, but they don't traffic shape to that 100 megabits per second. They police, which means anything above 100 megabits per second is dropped. What that happens is that creates packet loss. So on your side, you've actually got to traffic shape to the bandwidth that they provide. But in reality, there's also overheads and things like that. So, you know, if you bought 100 megabits per second, you're not going to get 100 megabits per second from them unless they provision at 110 or 120. If they sold you 100 and they provision at 100, for you to get 100 is never going to be achievable. You only get consistent traffic shaping if you go at about 91 megabits per second. So all of these things that happen in how ISP manages links, one of the benefits that SD-WAN does provide is it actually solves this for you. It can actually clamp the speed to what you get so that you don't have debilitation in your experience. You can also go back to the ISP and say, listen here, you know, here's the problem, especially because you're monitoring it and you're monitoring the experience from the client perspective, not from the ISP perspective, who can actually only monitor the uplink and not the downlink. So, 20 years later, same problems, same solutions, things don't change. But hopefully now with SD-WAN, we can actually go about keeping and making ISPs more honest, especially FNOs and those guys that actually provide the layer 2. Thanks for joining me on this little quick webinar, and see you on the next one.